Thank you. Okay, so
Where's
we're
my
going to
music?
be learning about you guys. Oh, you guys don't hear? Hold on one second.
Yeah.
Okay, there we go. So today we're going to be learning about fractions and decimals because they're one and the same. They're just different ways of writing them. And in order to learn about fractions and decimals, we need to understand how to multiply decimals. So when we multiply decimals, we ignore the decimal and the decimal is the little dot. See, the little dot. The decimal until the last step. Okay. Example time. I'm going to be doing so I want to do, oh, I won't make it dollars. I'll just do 40 times 0.2. So we haven't learned really how to do it yet, but try doing this on your paper. You're just going to, what I want you guys to do is just multiply the number 40 by the number 2. Act like the decimal's not even there. I mean, you should, write the whole number, write the decimal, but ignore the decimal. Multiply just like we normally do.
I'm done.
Okay, so just take a second to stop working on it. I just want you guys to watch me as I go through this because we'll be doing plenty of examples. So I'm going to ignore the decimal until the last step. So we do 2 times 0 is 0. 2 times 4 is 8. And then we're on to the second place right here. And so this 0 isn't really a 0, it's a 0 in the tens place. And since 6 is 0 in the tens place, we're going to give it a 0 right there. So we're going to do 0 times 0 is 0. And 0 times 4 is 0. And then we're going to add it. 0, 8, 0. Okay, so this is where we're at currently. So, what is the last step? What is the last
Bring
step?
down the decimal.
Almost. Oh, we have to bring it down, yes. But where does the decimal go? Well, let's find out. So we have to do 2 more things in order to find out where it goes. First, we count how many. You could say digits. Yeah, you could say digits. It's probably better to say place values, though. How many place values are to the right of the decimal in our question? So that might sound like a mouthful, but it's not too bad in our question. We're gonna do it right now. So you see, the first step is we multiplied like normal. So we had 40 times 2/10, or 0.2. And we just did 40 times 2. We found out that's 80 at the moment. 40 times 2 is 80, but we need to add the decimal. So this step, we're going to count how many numbers are to the right of the decimal. All right, well, we're looking at these two numbers, the numbers in our question. These two numbers, the numbers in our question, okay? So let's look at the number 40. I don't see a decimal on this number 40. Does anyone know where that one is? Where's the decimal on this 40?
Behind the 0.
Yep, it's just to the right of the 0, right over here. And you see, if we just write a number like 40 and there's no decimals, right, or there's no like tenth or hundredth, then we don't need to write the decimal. But we're going to write the decimal here for this example, just so we can see. Okay, so remember what we're doing right now is we are counting how many place values are to the right of the decimal in our question. So we have two different numbers we have to check. We have to check our 40, and we have to check our 2/10. Well, this 40, the number 40, how many numbers are to the right of it? Do you guys see any?
0.
I don't. Yes, 0. This 40 has 0 numbers to the right of the decimal. And as such, we're going to be adding 0 for this step. Or, 0 so far. Currently, there are 0 numbers to the right of the decimal. And then now let's look at the number 2/10. This is how you say the number 2/10, 0.2. If I look at the number 0.2, how many place values or how many numbers are to the right of the decimal?
1.
1. That is correct. There is 1 number to the right of the decimal. And, and so for the 0.2, I'm gonna have a 1 here. You guys don't have to write this. I'm just writing on, yes, right on your screen. But I mean, you don't have to write it every time you guys are solving multiplication problems. But now, what does this tell me? This tells me that in the question, there is a total of 1 number to the right of the decimal. You see, there's no numbers to the right of the decimal in the number 40. And there's 1 number, a 2, to the right of the decimal in 0.2. And so we're going to add these numbers up to see the total amount of numbers to the right of the decimal in our question. And that would be 1. Right? 0 plus 1 is 1. And so all we need to do, the last thing here, is make sure the answer has the same amount of place values, or I guess numbers. I can just write numbers, fine. Numbers to the right of the decimal. So you guys see our question, the question, we multiplied 40 times 0.2 and we found a total of 1 number to the right of the decimal. And so we want to make sure that our answer also has only 1 number to the right of the decimal. And so if our answer is 080, I'm going to start at the right and count in 1 time. And that's because I want to make sure that my answer only has 1 number, 1 digit, 1 number to the right of the decimal. And so I'm going to put right here. And see, that's going to make it, if I put my decimal right here, that's going to make it so there's only 1 number to the right of the decimal. And in this case, it's 0. And so our final answer is 40 times 0.2 is equal to, it's just 8. It's just 8. The reason is because we have 0 in the tens place, so there's 0 tens, so we don't really need to write that. We have an 8 in the ones place, and we have a decimal, and we could write decimal 0 if we want. We really don't need to, though. 8 or 8 decimal 0, that's all right. So I'm going to write a handful of questions on the board. I want you guys to solve them on your own, and then we'll go over a handful of them. Great, okay. So, here's the questions that we have. We're going to have... Well, I need to make sure to do ones that aren't terribly difficult. What about... I already did 40. 45 times 0.60. And we're also going to do 75 times 0.35. And we're also going to do 90 times 15 hundredths. That's how I say this decimal. We probably don't have time to go over exactly why we call it that yet. We might do it later. But that's all right. 90 times 0.15. You just say 0.15 for now, while we're still learning. Oop, this one might be a little bit tricky. Maybe two more. Okay, those are the 5 you solved. So go ahead and solve this right now.
How long are you gonna give us?
A bit.
10 minutes? 5 minutes?
Just work on it.
done.
Are we about ready to start going over it?
Oh, I'm barely 3 answers in.
Okay, so wrapping it up. Okay, I'm gonna have to start going. It's alright if you're not done. Just follow along. Okay, so we're going to have 45 times 0.60. Oh boy. Oh, there we go. Okay, 0.6 times 45.
Do you have to write this?
Yes, 5 times 0, 0. 5 times 6. 5 times 0 plus 3. And so now we're doing the 4, and since the 4 is in like the quote-unquote tens place, we write a 0, or I write an X there to show I'm in the tens place now. 4 times 0 is 0. 4 times 6, 24. Oh, 24, it doesn't matter. And then 4 times 0 plus 2. Okay, so see, we're doing everything like normal so far. But now that we reach this point, now what do we do?
Count down
Well,
decimal.
yeah, we have to count the decimals. We have to move the decimal. So, well, I'm not able to see. Okay, well, what it says here is, first we count how many place values, or numbers, are to the right of the decimal in our question. So let's go ahead and do that. In our question, we have two numbers, 0.60 and 45. 0.60 has 2 numbers to the right of the decimal. And 45, how many numbers are to the right of the decimal for 45? 0. See, because the decimal is just to the right of the ones place, 5, and there's nothing to the right of it. And so in the question, we have a total of 2 numbers that should be to the right of the decimal in our answer. And so that what this tells us is we can start from the way right of the number and count in 2 places, and that's where our decimal is going to be, because our answer needs to have 2 places to the right of the decimal. And so see, now our answer has 2 places to the right. And so if I do 45 times 0.60, I get 27. Okay, let's do this next one here. I'm gonna have to start speeding it up. Actually, what I'm gonna go ahead and do is I'm gonna skip these for a second because we don't have too much time. And instead, I'm gonna do these 2 because I'm hoping you guys haven't really gone to them yet. Or actually, never mind. Maybe I should go over the ones you guys did. 0. I'll do 0.3 5 times 75. 5 times 5, 25. 5 times 3, 15 plus 2, 17. 5 times 0 plus 1 is 1. Now we're doing the 7. That's kind of supposed to be in the tens place, so nothing in the ones place. 7 times 5 is 35. 7 times 3, 7, 14, 21 plus 3 is 24. 7 times 0 is 0 plus 2 is 2. 7 plus 5 is 12. 1 plus 1 plus 4 is 6. 2. Okay, and then the last step is to find out how many numbers we have to the right of the decimal. So for the number 0.35 or 35 hundredths, we have 2 numbers to the right of the decimal. And for the number 75, we have 0 numbers to the right of the decimal. And so we actually have the same deal where we're going to count in 2 places from the right for our answer. And that's where the decimal will go. Okay, next one. 0.15 times 90. So this first line should be easy because 0 times whatever is 0. So 0 times 5 is 0, 0 times 1 is 0, 0 times 0 is 0. Great. Then we have 9 times 5. If our trick is 45. 9 times 1 is 9 plus 4 is 13. 9 times 0 is 0 plus 1 is 1. Then, how many should I count over? Well, the number 0.15 has 2 numbers to the right of the decimal. The number 90 has 0 numbers to the right of the decimal. And so our answer should have 2 numbers to the right of the decimal. And so it's going to be right here. So you see I counted in 1, 2 from the right, and then that tells me where to put the decimal. So I'm going to stop for a second and do a little bit more of instruction before going over these last 2. So what's another thing that I want to teach us? Okay, maybe I'm just going to cave and type this one because I don't really feel like writing the whole thing. Okay. We can change between a decimal and a percent in one step. Yeah. So my first example will be decimal into percent. Hey guys, this is where our Latin root words paying off finally. If we take a look at decimal, we remember deci, 10. Deci means 10. And cent, cent means 100, right? So, how do we turn a decimal into a percent? Well,
times about 100.
To turn a decimal into a percent, you multiply the decimal by 100. And when you guys think, if you're like, oh, I want to turn this number into a percent, cent means 100, right? So that should help you guys out a little bit. So that is how you turn a decimal into percent in one simple step. So let's do an example. EX how do I turn the decimal 0.75 into a percent?
Multiply it by 100. It's 75%.
Yep, so 0.75 times, that's the times sign. Students, no writing on Mr. Barry's screen. I am teaching. No more, students. 0.75 times 100. Remember, cent means 100, right? There's 100 cents in a dollar. 75, yeah, 0.75 times 100 is equal to 75%. And then you do the exact opposite for turning a percent into a decimal. So, percent into, I'm going to add a little line here so it looks more like an arrow. Percent into decimal. To turn a percent into a decimal, you divide the percent by 100. And so for this one, I'll do a different one. EX. Okay, guys. So I'm not sure if you guys noticed this yet, but you see in my example, we turned the decimal 0.75 into a percent, 75%. And you guys see the decimal 0.75 is the very same one you guys are doing for question 4 here.
Oh, Mr.
Right?
Barry,
Yes?
I ripped my paperwork.
You can get another one.
I ripped my paper.
Go get another paper. So I'm going to use question number 5, the example here, 0.9. Well, I mean, it's already has decimal, but 90% divided by 100 is equal to 0.90 or 0.9. These are the same numbers. And so I wanted to make that clear. We could turn 90% into 0.9. So this 0.9 is the exact same as 90%. Okay, great. Ooh, we kind of went a little bit over. Or I guess I could do this. Close enough. Alrighty, so what does this mean? Well, for this 60 times 0.75, you might think, who would ever do this problem in the world? I don't need this problem. Who's ever going to do this problem ever? Well, this is a very common type of problem because this 0.75, remember we just learned we could turn a decimal 0.75 into a percent by multiplying it by 100. And that gives us 75%. And here's a little trick, guys.
I have no more space in my paper.
Another paper, the back of the paper, 2 papers. So here's another trick, guys. If I want to multiply 0.75 times 100, there's actually a pattern you can remember just for now. You don't really need to know how it works just quite yet. But if we take this decimal and move it to the right 2 spaces, that's the same as multiplying it by 100. So you guys see the pattern? See, I just if I want to do 0.75 and multiply it by 100 in my head, I can move the decimal to the right 2 spaces. And then, see, that instantly tells me it's 75%. So, yeah. Now, here's something that's very important to note. You can't use a percent in your multiplication. If I did 60 times 75%, that doesn't work. You can't multiply a number by percent. Instead, if I want to multiply a number by percent, first I need to turn it into a decimal. In this case, it's already a decimal, but it's not always going to be a decimal at the beginning. But right now, we're just practicing with decimals. Okay, great. So what I'm making very clear is when we're doing 60 times 0.75, that's the same as 75% of 60. That's what we're solving right now. We're about to solve that. So let's go ahead and solve it. Zero times everything is 0. 6 times 5 is 30. 6 times 7. Ooh, what's that one? 6 times 0 is 0 plus 4 is 4. And then our last step is to count the numbers after the decimal in our question. So there's 2 after the decimal here and 0 after the decimal here. So there should be 2 after the decimal for the answer. And that is our final answer. 45 is 75% of 60. And that kind of makes sense, right? 45 is 75% of 60 because half of 60 is 30 and half of 30 is 15. So a quarter of 60 is 15. And so 75%, 3/4 of 60 is 45. So let's go ahead and find 90% of 50. I could also do this one in my head. I'm actually going to do it in my head right now before we do it. So we have 50 and we're finding, remember we could turn this into a percent by just multiplying it by 100. So if I move the decimal to the right twice and add a 0 where I moved it, I end up with 90%. Or you could just do 0.9 times 100. You'll get 90%. And so I'm finding 90% of 50. Well, is there an easy way to find what 10% of something is? What is 10% of 50? I could do that in one step. Well, all I need to do, if I want to divide 50 by 10, I could just move the decimal to the left once. And that gives me 5. Yeah, I don't want to confuse you guys any further. So I'm just going to actually go ahead and get started with the math, because you don't need to know all these quick tricks I'm doing. All you need to know right now is multiplying fractions and turning fractions into decimals. That's it. 5 times 9 is 45. 5 times 0 plus 4. So we're going to get 4, 5, 0, and then we have to find out, let me write this a bit better. X, 5, okay. And for our question, we have one number after the decimal for 9, 0.9, and then we have 0 for the 50, and so 1, 0, and so we want one number to the right of the decimal for our answer. Great. And so 90% of 50 is 45. Hey, that's pretty funny. I didn't plan that. Take a look-see. 75% of 60 is the same as 90% of 50. Neat. So the answer to both of them is 45. Is that what you guys got? Interesting. So now let's start getting into what does this mean for us? Oh, I better click that before it disappears forever. Why does this show a weird box? Strange. Okay, so can I turn this down a little bit? No, I can't. So, some more practice problems. I'm going to type these because we're kind of running out of time. What is 85% of $160. What is? So start solving these right away. Mm. That's fine.
Done.
One more question. So, I'm sure you guys know this, just making sure you guys do. In order to do each of these problems, we're going to need to turn the percentages into decimals by dividing by 100. And so, like for example, 85% is equal to 0.85.
I'm done.
Hello, Dunn. I'm Mr. Berry. Well, if you're done just so fast, how about you do some more problems?
Never mind, I still have a lot to do, Mr. Berry.
Maybe one more extra. Just one more extra problem. Let's see if I can think of an extra problem. Ooh, you know what? I'm gonna pull out a calculator on this one real quick. All right, here's the extra one. Okay, you guys are gonna have to work your mind. I have not taught how to do this yet. You could definitely work it out though, okay? But it should be a bit difficult. So here's the extra problem is, what percent of 90 is the number 28.8? What percent of 90 is the number 28.8? So you're gonna have to kind of work backwards a bit, huh? So yeah, we're kind of winding the lesson down a bit too. So yep, just go ahead, take your time, wrap up, make sure you're like writing all the notes down, but we won't be doing too many more problems, maybe a couple. One thing I really want you students to do as well is when you find the answer, so like, see, I just did this, I want you to write down what percent that number is of the number we had in the first place. So take a look. For question number 1, we were finding 85% of 160. And so we found that 85% of 160 is 136. And so what I would write is 136 is 85% of 160. Technically, we should have dollar signs because I had a dollar sign in the question. $136 is 85% of $160. Great. Okay, let's take a look at this next one. I do want you guys to all try on the extra, though. Try on the extra.
I have 2 answers, but I think that they're both wrong. But then I don't know what else to do.
That's all right. I have not taught it yet, so don't feel discouraged. So, I just kind of want a show of hands. All right, just give me like a little thumbs up. It doesn't have to be big. Give me a thumbs up if you got 1 correct. Okay. Having a little bit of problems. Still having a little problems. Okay. I'm going to do, after I talk about the extra credit, real quick. I'm going to do maybe like 2 more problems that I'm hoping we could do together as a class, just to make sure that we got it. These problems are like the most fun you're ever going to have in math, all right? At least that's what I think. If you have fun with these problems,
Is it one of those problems that we did in class? Like, what is this out of this?
I don't think we're quite ready for everyone to be doing that.
maybe it's that.
Oh, so remember, when I'm done with this one, I find 42. So remember, I did 280 times 15 hundredths, or 0.15. 42 is 15% of 280. And once again, I use dollars. Usually, we use dollars with this, so it makes sense. Okay, last example. Okay, so here's where it might be tricky. So, you guys see, we've had examples, and most of our examples are like this, where our percent is less than 100. See, 85% is less than 100%. 15% is less than 100%. If our decimal is less than 100, if our percent is less than 100, then our number is going to get smaller, right? Because like say I have the number 100, or I have 1 crisp dollar bill, right? If I have $1 and I want to find 100% of $1, how many pennies is that? How many cents is in 100% of a dollar?
1.
100%. 100% of a dollar. 100 pennies. If I have 100% of a dollar, that's 100 pennies. If I have 1% of a dollar, that's 1 cent, right? 1%, 1 cent. Great. So, if I have less than 100%, my money will get smaller. For example, 100% of a dollar is 100 cents. 99% of a dollar is 99 cents. 50% of a dollar is 50 cents, right? Or 50 pennies. So what happens if the percent is more than 100? That's what we're doing right here, which is a little bit strange. But what happens if it's more than 100? Well, the number's gonna go up. So if I had 135% of a dollar, can anyone do that in their head? 135% of a dollar. Yeah, that's absolutely correct. That's $1.35. How do we know that? Well, right now we're working with $1, which is like the easiest thing we can work with. And I'm just talking about it. 1% of a dollar is 1 cent, right? Percent, 1%. That's where cent comes from. And so, 1% of a dollar is 1 cent. So 135% of a dollar is 135 cents, or $1.35. So you see, our number got bigger. Our number got bigger when we found a percent that's bigger than 100. So that's what's going to happen here. So 135 divided by 100. I could divide by 100 in my head by just 135. You see, this is where the decimal is right now, right? If I move the decimal to the left once of any number, anytime I ever feel like it, that tells me what that number divided by 10 is. 135 divided by 10 is 13.5. But I want to find out what 135 divided by 100 is. And so if I move it to the left twice, that tells me what it is divided by 100. So 135 divided by 100 is 1.35. 1.35. Great, and so this is the number that we're going to be multiplying. This is the decimal we're going to be multiplying our number by. So let's go ahead and do it. Good, I'm glad that I'm seeing people looking down and writing this. Thank you. Okay, 1.35 times 50. So remember, our number's gonna get bigger this time. So we multiply like normal. 0 times everything 0, 0, 0. Okay, now we're on the second. We're in the tens place now. 5's in the tens place, so we're going to put a 0 in the ones place, or an X, or it doesn't even matter. 5 times 5 is 25. 5 times 3 is 15, plus 2 is 17. 5 times 1 is 5, plus 1 is 6. Great. And let's see where the decimal goes. We have 2 numbers after the decimal here. And we have 0 numbers after the decimal and 50. See, 50 has a decimal right after it. Every single number in the world has a decimal somewhere in it. But if it's a whole number like 50, we just normally don't write the decimal because we don't need to. But we need to know that it's there. And so we have 0 numbers to the right of the decimal. There's no numbers to the right of it, so 0. And so our answer should have 2 plus 0 numbers to the right of the decimal. It should have 2 numbers to the right of the decimal. So 1, 2, boom. That's where our decimal should go. And so take a look. Take a look at what our answer does. For 1, we know that our answer, 67.50, and this I'm going to write it, 67.50, is 135% of 50. And you guys will notice, see, 67.50 is, thanks this percent is more than 100, 67.50 is bigger than 50, right? Our number got bigger. So we use this a lot, especially in like video games, where we want numbers to go up sometimes. So like, let's say I have a sword, right? And I do a magical enchantment on my sword. Yeah, I'll save this for our last example. Okay, extra, what percent of 90 is the number 28.8? Well, this is what we need to do. We're kind of working backwards. 90, so we're trying to find the percent this time, right? Okay, 90 times, so this is where the percent should go, right? Some percent, we don't know the percent, is equal to 28.8. Well, for 1, is 28.8 bigger or less than 90? Less than. So that means that this number, this percent, is going to be, yeah, correct. This percent is going to be less than 100. We know it's going to be less than 100.
Look at the button.
Yeah.
50 is, thinks this percent is more than 100.
Absolutely, that's me. But let me finish the lesson. We have 90 times some percent that is less than 100. Okay. Well, I could try plugging in numbers. Another thing that I could do is I could do 90 divided by 28 point... Whoop, wait, did I do that right? No, I did not. 28.8, sorry. 28.8 divided by 90. There we go. Whoop. And I'm not going to do the math right now, but the answer is, just so you guys can check, 0.32, or 32%. 28.8 is 32% of 90. Do you guys get that one? Okay, yeah, we are clearly running into history time now, but I think it's worth taking 2 more minutes to go over this example real quick, because this is the fun example. Yay! Okay, Mr. Berry's magical Minecraft sword. Oh, it's not magical yet, I guess. It will be. Mr. Berry's Minecraft sword normally does...
10 attack damage?
7 or 8?
I'll just say 8 for now.
Mr. Bird, do we
8.
need to write this problem?
Yeah. Attack damage. normally. But he enchants it to make it deal 25% more damage than usual. How much attack damage does the sword do?
I know.
Do the math, students.
I think I can do this one in my head.
And it's alright, I just want you guys to write it down. I'm not expecting you guys to do it. So, it normally does 8 attack damage. Now, here's the thing. I enchant it, and so it's going to deal 25% more damage than usual. So, I don't want to find what if I wanted to turn 25% into a decimal, that would be 0.25. Remember, to turn a percent into a decimal, we divide by 100. So, I don't want to find what 25% is, though, because look, if I do 8 times 0.25, that's going to give me... What's that going to give me, Imuna? 2. That's going to give me 2, but look, that doesn't make sense. My sword isn't going to get less damage. That doesn't make any sense. And so, what is this decimal actually going to be? Yeah, so I'm going to add 2 to 8, but this decimal is not going to have a 0. It's not going to be 0.25. It's actually going to be 1.25. And the reason is because the number is getting 25% more than what it normally is, which is 100%, right? If my sword is dealing 100% damage, that is all of its damage. So 100% of 8 is 8. And so for me to find 125%, that's what I'm doing right now. I'm finding 125%. I would do 8 times 1.25. And so 1.25 is 125%. And that will give me 8.125. If you guys do that, that's going to get you 10. Which is 8 damage, 100%, 8 damage plus 25% damage. And so if this is a little bit, if you guys are still having a little bit of trouble understanding this, that's all right. This is, covering quite a bit. But this is exactly how I would write the code in one of my games. I would say damage. And if I want to deal 25% more damage, I would do damage times 1.25 equals new damage. And so this is exactly what we do in coding. So I think that's really cool. Great, and that is going to be the end of our recording.